Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model for YOLOv8 segmentation. We are going to create our custom model with the help of Raspberry Pi 4 and Google Colab, and then we are going to detect our custom object. So custom object is basically our Arduino Uno board and ESP32 board. So before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we are going to create here our own custom model for YOLOv8 segmentation. So for that, first you need to install latest opencv and YOLOv8 on Raspberry Pi 4, Raspbian OS Bullseye 64-bit version. I have already created the video how to install YOLOv8 on Raspberry Pi 4, Raspbian OS Bullseye 64-bit version. I will mention video link, watch video and install opencv and YOLOv8 on Raspberry Pi 4, Raspbian OS Bullseye 64-bit version. So I have already done with opencv and YOLOv8 installation steps. So as I mentioned, we are going to create our own custom model, object detection model for YOLOv8 segmentation. For that, I have created here a repository rpi4 YOLOv8 custom segmentation. I will mention link, copy and paste the link inside the browser, then go to the code, copy the link from here, open terminal, and we are going to clone our repository. So run the command git clone and paste link and just hit enter. It will clone our repository. Now we have our repository. So if I run ls command, this is what our repository, as you can see. So we need to go inside the repository. So run the command cd rpi4, press tab, and now we are inside our repository. So let me run clear command. So if I run ls command, so this is what basically our Google Colab file for training purpose, and this is the img.py is basically capture our object images. This is basically Python code for creating our own data set. Simple. So we are going to open our img.py with the help of Thony Python IDE. So I have connected the USB camera with the Raspberry Pi 4. So we are going to open our Thony Python IDE. So Thony Python IDE. Then go to the file, click on open. Then pi, and this is what our repository rpi4 YOLOv8 custom segmentation, and inside that we have our img.py. Simple. So we have opened our img.py, and this is the Python code for capturing our data set. So right now I have mentioned here max frame 30. If you want to increase the frames, you can simply mention the number of the frames, like you want to go with 100 frames, so it will capture each object 100 images. Okay, each object 100 images. So right now we are going to only capture 20 images because we are going to create a video. So if I make more images, the video will become more long. So just 20 images for each object. As I mentioned, we are going to capture here Arduino Uno board images and ESP32 board images. So each board we are going to capture 20 images. So let's just start with Arduino board. So here cv2 write, it will capture our images and it will save the images in the folder. So we need to mention here a folder name. So what we are going to do, we have our repository. Okay, so here /home/pi, here I am going to create images folder. So just create the images folder. Okay, so in this images folder we are going to save our images, and then we are going to use these images as our data set. So simply we need to mention the path over here. So images /home/pi and /home/pi, and then we have our images folder, and inside that first we are going to capture Arduino images. For that I have mentioned here the name of our object is Arduino. Simple. So it will capture 20 images. So now what we want to do, as I mentioned, I have connected the camera, USB camera with the Raspberry Pi 4. Now we need to simply move our Arduino Uno board in front of our USB camera in different angles slowly. it will capture all images. Okay, so just save the code, and if I run the code, as you can see friends, I am moving Arduino board in front of our USB camera slowly. So if I open folder and inside images, as you can see we have 20 images. So if I open the images, here it is, as you can see we have images of our Arduino Uno board. So simply what I am going to do, I am going to again capture all the images, okay, because this is just for testing purpose. So we are going to create all new images. So start with Arduino Uno board. So if I start the code, so we have done with Arduino Uno. Now simply here I am going to mention ESP32 board name. So ESP-32. So this is what this will basically capture ESP32 20 images. So if I save the code, and now I need to set ESP32 board in front of USB camera, and as you can see this is what our ESP32 board, and I am moving the board in front of USB camera. So we have done, we have Arduino images, also we have our ESP32 board images. So if I open, as you can see this is what Arduino board, and then we have ESP32 board images. So done, we have our data ready. Now what we are going to do, for training purpose we are going to use here a Roboflow. Okay, so friends, this is what Roboflow website, and of course we need to first create our account. So we can use our own Google account, or we can go with GitHub. So I am going to sign in with Google. So just click on sign in with Google. So friends, we have successfully signed in with our Google account, and Freedom Tech is my account. So here we are going to start with creating new project. So simply we are going to click on create new project. So click on create new project, then just click on explore solo, and we are ready. Okay, so here we are going to we need to basically mention our project type. So simply we can say instance segmentation, because we are going to use here YOLOv8 instance segmentation. So just click on instance segmentation. Then what are you detecting? So let's just say electronic. Okay, electronic. So we are going to detect basically here electronics boards, which is Arduino Uno board and ESP32. So you can mention here as per your object, you can mention what basically you are detecting. So I have just mentioned electronic. So project name, so let's mention RPi4 YOLOv8, RPi4 YOLOv8, then segmentation. Okay, so our project name is RPi4 YOLOv8 segmentation. Simply click on create a project. That's it, we have created our project. Now we need to upload our data. So simply what we are going to do, just open the images folder where we capture our images. So this is what our images folder, and we are going to simply drag and drop our images folder. So just drag like this way and just put inside here. It will copy all the data. As you can see, it says the processing files. That's it, we have now our images. Now simply click on save and continue. That's it, done. Upload complete. Assign images to templates. Simply here you need to mention let's say I have mentioned here Freedom Tech, this is just a name, and I have mentioned here my Gmail ID. Simple. So you need to mention name and the Gmail ID. So just click here. As you can see, I have clicked it, and then the pop-up message assign images, simply click on assign images. That's it. So now we have successfully uploaded our images. Also we have assigned the images for my email ID. Okay, so now we have done. Now we are going to create annotation. So simply here it is, as you can see, unannotated 40 images and annotated 0, because we want to create annotation. So simply we are going to select our first image. So this is what our first image. Simply click on, and then it will open this kind of page. As you can see, this is what the page where we are going to draw a polylines on our image. So we want to select this, as you can see, polygon tool. If I start with this one, so this is the first, second, the rectangle bounding box tool, and third one is, as you can see, polygon tool. So select it, polygon tool. And then what we want to do, we want to draw the polylines. Okay, so if I go with here, just left click from the mouse, and then you will see this kind of white box. Click it and it will draw the polylines, as you can see. Okay, so here this is the first step. Now we want to go with another side, so just again left click. From here now we can draw another line. Again left click, just go here, again here left click, here left click, this side left click, then we are going to go here, left click, and then this is here, left click, again left here, and then just touch the box where we start. Then you will see the green color box. Okay, if, as you can see, if I touch this side, we can see basically we can complete our polyline. So now we can mention the class. So this is what our Arduino Uno board. So we are going to simply mention classes. Just a minute, we are going to draw again polygon. So just click, left click, then draw the polyline, then here also, then here also. As I mentioned, when we want to change the line, again we need to left click the mouse. Okay, so here we completed this shape, so we are going to draw this side, complete this side, left click, another side, left click, go up, left click, here left click, here also, and then just touch at where we start. And then we can see here we need to mention the class. So we are going to mention the class Arduino hyphen Uno. Okay, Arduino board. This is what our first class, Arduino board. So just save it. Okay, so now go to the next image. Okay, this is what our second image. Again just left click mouse. Okay, it will draw the polyline. If you click the left button and if it is the line is not available, just click again. Okay, just click again. So we have complete this side, so left click, complete this side, left click, this side, then here, then go up, complete, so left click, here complete, left click, this side, this side, this side, this side, then this side, and then we are going to merge it. Then we can see the green color box. That's it. And then the class is same because this is what our Arduino Uno board. So simply click on save. We have done with second image. So next image. So on third image, same way, left click, draw the polygon. Again we have done with this side. So we need to go down. So again left click, done, left click, this side left click, then just go up, this side left click, here also left click, go up, okay, then here left click, here left click, here left click, go down, then here left click, go up, left click here, and then touch, just left click. Then we can see again we have the class. So same class because this is what our same board. So just click on save. So this is how you need to draw the polygon on object. Okay. So I am going to now draw the polygon on Arduino Uno board. When I have complete the Arduino Uno board and when we have our next object, which is the ESP32, I will again start the video. Okay friends. So friends, I have done with drawing polygon on Arduino board. Now this is what our ESP32 board. Same way, just left click, then we are going to draw a polyline here. Again left click, go here, again left click, go up, again left click, go here, then just little bit up, then here, 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 and just touch where we start our polyline. Then we can see the box is green, just click, and then we can see we need to mention the class. So this is what our ESP32 board. So just mention ESP32, simple, ESP32, and just click on save. So this is what our second class. So go to the next image, same way, left click, start. As you can see now there is no line, so no worry, just again click, left click, then we can draw the line. As you can see here also same way, left click, then here also, then here, then just here, then go down here, and then just merge. Okay, as you can see again green color box, and we can see we need to mention here class. So same class ESP32, save. Next image. Okay, so just left click, as you can see no line. So as I mentioned, no worry, just again left click, it will draw the line. Okay, for here left click, again go up. So we complete the line. Now again we need to go with new line, so just left click, then here, okay, then here, then just touch it. Okay, then ESP32 class. Next image, left click, okay, left click here, up, then here also, here, and then just merge. Then we can see we need to mention our class. So save, because this is the same image, ESP32, save. So this is how now I am going to draw the polygon on our ESP32 board. Okay friends, one more thing I just want to mention here. Suppose if you are doing annotation job and if the internet is gone or something, the page is hang, so no worry, because where we finish our job, it will save the images, and as you can see annotate 17 images, means I just want to annotate the 70 images and I have completed 23 images, means it will save our job. Okay, so it will save our job. I have completed 23 images and I need to go for 17 more for annotation job. Okay, so here, from here I need to start again annotation. So I am going to simply click here, and then as you can see it says 117, means I need to complete the only 17 images. Okay, so if you are doing the work and if the page got hang, so no worry, it will save your previous job. Okay, so friends, we have successfully draw a polygon on our all 40 images. Okay, so now what we want to do, as you can see, I have also completed the images which I have left, the 17 images. Okay, so now simply we are going to click here. Okay, so as you can see, annotate 39 plus this one, the first image. So we have completed our 40 images annotation. So simply what we want to do, simply click here, add 39 images to dataset. Okay, so just click. Okay, then this is how it will create the dataset. 70% for train, valid for 20%, and 10% for test. Simply click on add images, and that's it. As you can see, we have completed our data set. Now simply click on generate new version. So just click on generate new version. Okay, then you will see this kind of page here, auto orient, resize. So simply we don't want to change anything here, just click on continue. Okay, then augmentation process, just click on continue. Then generate process, just click on generate. No need to change anything here. Okay, that's it. We have done ARPy4 YOLOv8 segmentation image dataset. We have done with our dataset. Okay, and if I just go down, here it is. As you can see, 27 train images, valid 7 images, and test 5 images. That's it. We have done with our data. Now what we want to do here, as you can see, export. Okay, so now we are going to export our data set in our Google Colab. So for that, first we are going to open our Google Colab file. Okay, so friends, as you can see, I have opened Google Colab, and here we are going to click on upload, choose file, and we are going to open our Google Colab file from our repository which we just cloned, ARPy4 YOLOv8 custom segmentation. Just click on, and this is what our Google Colab file. So just click on open. It's now uploading. So friends, we have successfully uploaded our Google Colab file. So first go to the runtime, change runtime type, select GPU, click on save, then click on connect. It's now connecting. So friends, as you can see, we have successfully connected. So let's just start with first code. Let's make sure that we have access to GPU. So it will basically check if we are accessing a GPU or not. Okay, so this is what the command. So we have done. So just scroll down. We are successfully accessing a GPU. Then we are going to run our second cell. Just click on a second cell, and it will run our second cell. Okay, so then we have done, and now then just scroll down, and then just a minute, this is what our we run this cell, second cell. Now we are going to move on our next cell. So here we are going to install Ultralytics on our Google Colab for YOLOv8. As you can see, this is the command. So just run the third cell, and it will install Ultralytics. Also it will import IPython import display. Okay, and then it will import Ultralytics. So we have done. So next cell, just click on, done. Then just scroll down for just a minute. So we have run this cell. So then next cell. Okay, so then next cell, here we are going to detect the image. Okay, the image link, here it is. As you can see, I have used here doc.jpeg image from Roboflow. Okay, So we are going to use here by default YOLOv8 segmentation model. So just run this one cell, and as you can see, process is ongoing. And done, we have done. So the result is like this way. Okay, result is like this way. We have bounding box, also we have segmentation. Simple. So we have done with by default model. So now we are going to move on our customization model. So here, as you can see, mkdir datasets. So right now there is no datasets directory. So it will create, we are going to create the dataset directory, and inside dataset directory we are going to save our data. Means we are going to save our all images which we train with the help of Roboflow. So simple. So what we are going to do here, just click on here. So this is the code. This is the code for Roboflow. So what we are going to do, we are going to delete this code and we are going to use our own code for our own data set with the help of Roboflow. So simply move on our page Roboflow and click on export. This is the same page, as you can see. So click on export. Then here select format. We are going to select YOLOv8 format, and then show download code. Just click on continue. It will generate the download code which we are going to copy paste inside our Google Colab. So as you can see, the code, this is the same code. Here it is, as you can see, same code, but we are going to use our own API key. In your case, you need to copy and paste your code. Okay, this is in your case. Of course, the API key is different. Simple. So just copy it, the code from here, like this way. Just copy it and just replace with this. Just copy and delete, and just press Ctrl+V, victory. Simple. That's it. We have done. Now simply run the code. It will create dataset folder. Also it will upload all the images which we train with the help of Roboflow. So process is going. We have done. So if I click here, as you can see, now we have dataset folder. Just click, and this is what our main folder, RPy for YOLOv8 segmentation. Then inside that we have test folder, the images folder, and as you can see, we have Arduino and ESP32 images. So now our data is ready. Now simply what we are going to do, we are going to create our own custom model. So this is what the next cell, the last cell, and with the help of this we are going to create our own custom model. Okay, so simply we are going to click on here and it will create our custom model with the help of 100 epochs, as you can see. So it started now. As you can see, it started the process, started with 0 epochs. Okay, so it will take some time. Meanwhile, I will pause video. So friends, we have completed our training, and as you can see, this is what our two class, Arduino Uno and ESP32, and our model is basically saved inside runs, segment and train. So just click here. Then we have here runs folder. As you can see, runs, click on runs. Then we have segment folder, as mentioned, run, segment and train. So we have segment folder. Then we have train folder, and inside that we have weight folder. So click on weights, and then base.pt. So this is what our custom model. So just click here, click on download, and now it will download our base.pt. So friends, we successfully download our model, as you can see, base.pt. Okay, now simply go here, click on show in folder, and it's inside /home/py download. So we want to move our model inside our repository. So just right click and cut, go to the home and our repository, which is rpy for YOLOv8 custom segmentation. Here we are going to paste our model. Okay, and now what I am going to do, I am going to minimize the browser and we are going to create our YOLOv8 Python script for detecting our object. Okay, so friends, I have opened Tony Python ID and here we are going to create our new file. So click on file, new, and right now the file is untitled, so we are going to mention the name. So click on save and go to the py. This is what our repository, rpy for YOLOv8 custom segmentation, and we are going to mention the name for our file. So test.py, you can mention any name, simple. So now we are going to first call our module. So from ultralytics, from ultralytics we are going to import YOLO. Okay, simple, just save it and we are going to cross check our module. And as you can see, I have run the code and there is no error. This is not error. Okay, this is not error. We have successfully run our module. So it means we successfully call our module from ultralytics import YOLO. Now simply we are going to create a variable. So model is just a variable. This variable is represent our module. So import YOLO. So model is equal to, we are going to mention YOLO. Okay, we are going to mention this YOLO. And inside that we need to mention our model name, our custom model name which we just create. So our custom model name is base.pt. Okay, if I open repository again, this is what our repository and this is what our custom model base.pt. Simple. So mention like this way in single quote base.pt, the name of our model. Then now we are ready. We need to call our variable model. So model.predict, and inside that we need to mention source. So source is basically a USB web camera. So I have here only one USB camera. So source index number 0. That's it. Then show is equal to true. T is capital. Simple. Show is equal to true. That's it. So if I save the code and if I run the code, and friends, as you can see, it's detecting our Arduino Uno board 90%. Okay. And as you can see now ESP32 with segmentation 95%. Okay, so we successfully detect our both board with segmentation. Okay, we only train 20 images. In real scenario we need to train more images for perfect segmentation and object detection. Okay, so this is how you can use YOLOv8 for custom object detection, also the segmentation. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.